Okay, 5.3 day 2, let's look at the cube root function. Yesterday we did square root. Okay, so the parent function of the cube root function is f of x equals the third root of x. So let's graph it to see what the parent function looks like. We're going to make a table to get it right, but let's pick some points that are easy to do a third root of. So let's start with 0. The third root of 0 is 0. Okay, what else is easy? Let's do 1. The third root of 1 is 1. Okay, what's another number that's easy to do a third root of? I'm going to do 8. Why am I doing 8? Because 2 times 2 times 2 is 8, so the third root of 8 is 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, up 2. Okay, now if I'm doing a third root, I can plug in a negative value. So if I do the third root of negative 1, I get negative 1 because negative 1 times negative 1 times negative 1 goes back to negative 1. Okay, which means let's also do negative 8. The third root of negative 8 is negative 2 because it's negative 2 to the third. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Does that look right? 1, 2, 3. Okay, now let's go ahead and sketch this curve. Okay, I just have arrows in both ends because I can plug in infinity and I can plug in negative infinity. Okay, so for our domain is the x values. For the x values, I can plug in negatives and I can keep plugging in more negatives. I can plug in 0 and I can plug in positives. So the domain is going to be all reals or all real numbers. For the range, well, I can plug in negatives and I get a negative answer, and it keeps going down forever. I can plug in 0 and I can plug in positives. So the range is also all reals. So there's no restriction. The graph goes all the way from negative infinity to positive infinity. Okay, now this is the shape of the parent function. We're going to translate them and then see if we can regraph them. So let's get the translation first, and then we'll look at the parent function again. Okay, so for this function, let's describe the translation from the parent function. Well, since the x minus 2 is in the radical, it's going to go right 2. Okay, so from the origin, it's going to go right 2. So let's go ahead and move it right 2. Okay, now the next 2 points, these little purple dots, one is 1, 1, one is negative 1, 1, because the third root of 1 is 1, and the third root of negative 1 is negative 1. Now, if there's room, I'm going to go ahead and include the third points on each side. This is the third root of 8 is 2. So let's try that. 1, 2, 3, 4, 5, 6, 7. Doesn't fit. Let's try it this way. 1, 2, 3, 4, 5, 6, 7, 8, down 2. The third root of negative 8 is negative 2. That does fit. Okay, then the shape of the graph is kind of this like flat sideways. It's a cubic function sideways actually. Okay, for my domain, well, in the x direction, there's a left arrow and a right arrow with no stop, so it's all reals, or negative infinity to infinity. And then for the range, it goes from down arrow to up arrow, so it's also all reals. Okay, let's try another one using translations. Okay, this is b is f of x equals the third root of x, and then it's plus 1. Since the plus 1 is at the end, this is going to move up 1. Okay, let's go ahead and take that middle point and move it up 1. Okay, now for the third root of 1 is 1. The third root of negative 1 is negative 1. Okay, from here I could sketch it, but if I can fit the other point I'm going to, the third root of 8 is 2. So from this center point, 1, 2, 3, 4, 5, 6, 7, 8, it does fit. I'm going to go up 2. And I'll go left and do the same. So from the center point, 1, 2, 3, 4, 5, 6, 7, 8, the third root of negative 8 is negative 2. Okay, and I include those points. It's just easier to get this curve right. Otherwise, it's really hard. Okay, domain range. Left arrow, right arrow, all reals. Up arrow, down arrow, all reals. Okay, let's do a couple more translations. Okay, what are we doing here? We're going left 2 because it's in the radical, and then we're going to go down 3. So let me move my center point. Left 2, down 3. I'm calling it a center point, but I don't think it actually has a special name. It's like a point of symmetry. Okay, from here, the third root of 1 is 1. So let's go right one, up one. Third root of negative 1 is negative 1. Okay, and then if I have room, I'm going to fit the third root of 8. So from here, 1, 2, 3, 4, 5, 6, 7, 8, up 2. That'll fit. If it'll fit on the other side, I'll do the same from the center point. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Okay, and I'm including those to get a better shape on my graph, but often those extra points don't fit. Okay, domain and range are still all reals. Cubic functions, actually, because it's a third root. I mean, you can third root negatives, that's why we get such an inclusive domain. Okay, one more translation. This is going right 5, and then it goes up 4. So I'm going to take my center, 1, 2, 3, 4, 5, 1, 2. Okay, then right one, up one, left one, down one. Okay, 8, no way 8's going to fit this way, but it might fit this way. 1, 2, 3, 4, 5, 6, 7, 8. The third root of negative 8 is negative 2. Okay, and then I'm going to go ahead and sketch it, and even if I don't have those points, I still know it's going to be kind of like flat. And it's going to go left arrow, right arrow, which means my domain is all reals, and my range is going down arrow, up arrow, so also all reals. Okay, so for example 2, let's do some other transformations. Okay, for a, f of x equals 3 times the third root of x. Since I'm multiplying by 3, it's going to get taller, so it's going to be a vertical stretch by 3. But it's not translating, so I'm going to go ahead and still start at 0, 0. Okay, vertical stretch means in the y direction, I'm going to go 3 times as high. So instead of going right one, up one, I'm going to go right one, and I have to go up 1 3 times, 1, 1, 1, or I have to go up 3 times as high. So instead of going up 1, I'm going to go up 3. Okay, now the same is true on the other side. Normally I go left 1, down 1, because the third root of negative 1 is negative 1, but I want to go 3 times as far. So left 1, down 1, 2, 3. Okay, now does the other point fit? Does the 8? 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7. Actually, it almost fits on the left. Let me include it. No, I think it's still not going to fit. Okay, let's go ahead and sketch it. This makes it a lot taller. So I'm going to guess it's going to flatten out and go something like this. Even though we are not sure exactly what it's going to do, try to make it look like it's flattening out on either on the left and the right. So that's very characteristic of a cube root. Let's try b. F of x equals the negative third root of x. Then that negative in front is multiplying the y value by a negative, so it's going to reflect it over the x-axis. Okay, but it's still at 0, 0 because it's not being translated. Okay, normally we go third root of 1 is 1, but they're saying times it by negative 1. So instead of going up 1, I'm going to go down 1. Okay, if I can fit 8, 1, 2, 3, 4, 5, 6, 7, 8. We normally go up 2, but instead we're going to go down 2. Okay, let me do the other side. Okay, I normally go left 1, down 1, but instead of going down, I want to go the opposite. I go up. 1, 2, 3, 4, 5, 6, 7. And then for negative 8, instead of going negative 2, I go positive 2, because when I times it by negative, it changes the signs. Okay, this is my graph. It still flattens out. Still looks like a cubic function. Let's add a few more steps with this. Okay, this one, for c, f of x equals negative 2 times the third root of x. It has a negative, so it's going to reflect the x-axis. But then it's being times by 2, so there's also a vertical stretch by a factor of 2. But there's no translation, so I'm going to start at 0, 0. Okay, normally we go 1, 1. But it's reflecting, so I'm going to go, instead of going up, I'm going to go down. And instead of going down 1, I need to times it by 2. So instead of going down 1, I'm actually going to go down 2. Okay, let's see if we can fit 8. 1, 2, 3, 4, 5, 6, 7. I'm going to pretend I can fit it. Normally I go up 2, but I'm reflecting, so I'm going to go down. And I'm going to go twice as far. So instead of going 2, I'm going to go down 4. 1, 2, 3, 4. Okay, let's do the opposite. Since we went down on this side, we are going to go up on the other side. And you can kind of tell the symmetry of it. So let me match these, and then if I can fit 8, 1, 2, 3, 4, 5, 6, 7, 8, not exactly, but I'll include it. Normally I go down 2, but I want to go up because I'm reflecting and I want to go up twice as high, so I'm going to go up 4. Okay, this is still a cubic function, so it does kind of level off on the left and the right. Okay, let's try one more graph. Okay, what is this doing? This is going left 2 and it's being times by 4. So this is a vertical stretch by 4, and it's going left 2. So let me go left 2 so I can kind of center it. Okay, from my new center, I normally go right 1 up 1, but I'm going to go 4 times as high, so I'm going to go right 1 up 4. 4. Okay, on the left, I'm going to do the opposite. Left 1, down 1, but I got to go 4 times as low. Okay, now if I were to go 8, 1, 2, 3, 4, 5, 6, 7, 8, it would be here, and I normally go up 2, but I would have to go 4 times as high, so instead of going up 2, I would go up 8, 2, 4, 6, which is going to be off my screen. So I'm going to sketch my graph. Even though it's really steep, it should still look like it's kind of leveling off eventually. It should flatten out up there, but it still looks like a cubic function because that's the characteristic of a cubic function. Okay, last example, we're going to write the equation for g of x with the transformation of f of x equals the third root of x. So these are all going to be cube roots. Okay, let's try. Okay, g has a vertical stretch by a factor of 4, and then it is shifted 3 right. And what is this third root? So the 3 right should be inside the radical. And then this should be called g. Okay, let me check it before I box it. Okay, g, vertical stretch of 4, shifted 3 right of f, and f is a third root. Okay, there it is. Okay, g is f, translated 2 units up. Okay, 3 units left, so I know that's going to be x plus 3, but this is f, third root. Okay, and then reflected over the x-axis. So then I need to times it by a negative. Okay, so g of x is going to equal negative third root of x plus 3, and now it's going to be minus 2. Okay, let me double check my information too. Okay, g is f, what's f? Third root, 2 up, 3 left, and then I times everything by a negative to reflect it.